Hello, everyone. My name is Vanpee. I am a senior test engineer extraordinaire here at Google, and I'm going to take 15 minutes of your time to talk about the Quirkier side of testing. Quick fun fact about me, I'm an identical twin, so if you want to come talk to me later, memorize the shirt I'm wearing. What is a quirk? So a quirk is an odd trait or behavior. So there we go. So here are some examples. So cats that have two different colored eyes because of a genetic mutation. Some people sort of build careers out of being quirky. The slides you see before you are actually in themselves quirky because one of them is actually a quirk, not a quirk. Programming languages, of course, have quirks, and that's what we're going to mostly talk about today. What are a few examples? So Objective-C. Has anyone coded in Objective-C before? Quick show of hands. Quite a few of you. Did you know that there is a property called HM characteristic value lock mechanism last known action unsecured using physical movement exterior? This Objective-C is very verbose. It's very quirky. This is 87 characters of greatness. There's also an interior, in case anyone was curious. JavaScript is everyone's sort of favorite language to pick on, so of course we'll do that. So null equals undefined. Does it? It turns out, yes, null is in fact undefined. Makes sense. Is null finite? It turns out that, yes, null is of course finite. Is undefined finite? No, because of course not. They're equal, but they're not the same. So that's another sort of quirk you see quite a bit in languages. That's why a lot of languages sort of introduce the triple equals operator that say that it's not just equal in value, but also in type as well. So null and undefined are the same value, in quotes, but not the same type. JavaScript's fun, so we'll keep going. Which is larger, 3 or 0? Hands up if you think it's 0. The answer is 3. Makes sense. But what's greater, 3 or true? 3 is always greater than the truth. Remember that? What's larger, -1 or an array of 1? An array of 1, because in JavaScript, the value of an array is the value of the first element. Makes sense. We can keep going all day, of course. What's larger, -1 or the empty set? 0. We all saw that coming. What's greater, -1 or undefined? Not a number. Not a number is greater than, that doesn't even make sense. Which is larger, -1 or null? Turns out the answer is 0. One thing you'll notice is null is pretty much 0 for all intents and purposes. So if you take a value, take null and add 1 to it, the answer you get is 1. Great. So some quirks are found in many languages. Here's an example in Java. So if I were to say print my name but with a nice fancy B on top, and then I get fancy and I'm going to make it all uppercase. It turns out what that actually does is that not only changes the value of the string, but changes the length of the string. So a little tidbit there, when you're doing testing, you always be careful about changing case when you're using Unicode characters. The two often don't mix. FYI. Some quirks are specific, and I lost my slides. Some quirks are specific to languages. And we'll pause here. Does that report?
Yeah, it is.
I will pause to take a drink.
Cool, that looks like that. We're just going to switch it back there.
There we go. As I was saying, none of that just happened. Some quirks are specific to a specific language. So here's an example in Java as well. So if I were to write post-increment operator is the new A post-increment operator. The answer, of course, is 0 is the new 1, because it takes A, prints it, then increments it, takes A, prints it, then increments it. So 0 is the new 1, A is now 2. Make sense? If you do the exact same thing in C++, 0 is the new 1? No. 1 is the new 0. That's weird. If of course here's the C equivalent, it does the same thing. So any sort of C variant does something weird that's not the same as Java. Why is this? So it all has to do with sequence points. So sequence points are defined in C as a point in time at which side effects have been guaranteed so far to be complete, and they vary from language to language. As you can see, Java and C C++ are different because of sequence points. C also defines that between the previous and next sequence point, an object shall have its stored value modified at most once. So as you saw, we modified it once. Then when we tried to modify it again, it had no effect because of sequence points. So again, our example 1 is the new 0 because A was incremented once, and you can't increment it twice in the same between two secret points. So that's why that works. In fact, if you increment B a whole bunch of times, it will never actually increment because this is equivalent. If you do B equals B++, it's actually not valid in C or C++ because what you're essentially saying is B equals B, then we increment it, but it's not assigned. Again, these are all sort of very in-depth about the post-increment operator. The pre-increment operator does work as expected because, of course, it increments, then it does the assignment. Wonderful. But this is the interactive portion of the talk, so I hope you're all not too full from lunch. So finding the quirk is all the fun. So I'm going to throw some examples at you, and I'm going to see if you can guess what the quirk is. So can anyone tell me what this does? Any guess? Returns 1, I heard. Well, it returns 1, 2, 3, or doesn't compile. Those are your options. It turns out that that has to do with the comma operator. So in many languages, the comma operator basically says always evaluate the left-hand side, then always evaluate the right-hand side no matter what. And of course, as opposed to the AND operator, which does one or the other, and OR as well. Not every comma is an operator, but you may have seen this before, for example, in for loops when you've seen this sort of syntax. So in this case, it returns the value 3 because it evaluates 1, evaluates 2, and then it returns 3 because the result of the expression is 3. Does anyone know what this does? It returns 3, which makes sense because just because I threw in some brackets in there doesn't mean I fool you, right? Does anybody know what this does? This, of course, also returns 3. You're starting to see the pattern here because the value of an expression is the expression. So does anybody know what this does? That's a syntax error. That does nothing. Ignore that. Can anybody give me a value for I that makes this statement true? What value is equal to its own negative? 0. I heard 0. Very well done. Not every quirk is a trick. In all these languages, 0 works. But is there a value for I that's not 0 that is also true? Sorry, was there a guess? Not a number? Close. Integer.mint value. That's a little weird. Why is that? If you remember that in most languages that treat integers as a 32-bit number, the range is -2 to 31 to +2 to 31 minus 0. So there's actually one more negative number than there is positive numbers. So if you take, for example, the negative number, which is 8 with a bunch of 8 sign bit, which is a bunch of zeros, and then you negate that, that's equivalent to saying take the integer max value, add 1 to it, and it turns out it's the same value. So long story short, integer.min value is its own negation. Fancy trick. Always be careful, especially when you're dealing with rollover situations. Get you every time. Is there any value that's equal to itself plus 1? Any guesses? Infinity? That's a great guess, and it turns out it's right. This is simple math. So any language that implements the 754 floating point spec defines an infinity value. So of course, infinity plus 1 is just infinity. Makes sense. Does anybody know a value for I that is not equal to itself? Is this even possible? It is possible, someone says. What value?
Yeah, not a number, JavaScript.
Not a number? That's an excellent guess. Turns out it's correct. Again, 752 floating point spec, there's a lot of detail in there. But the key is there is no, the spec defines not a number to be equal to nothing, not even itself, no matter what. Can anyone tell me what this does? So here's a quick show of hands. Has anybody seen the approaches operator before in any language? That's because it doesn't exist, of course. So the trick to this is most people are probably thinking the first line, you've got it. So it's equivalent to saying 5 minus -6, which is, of course, the value 11. The approaches operator is actually equivalent to I minus or minus is greater than 1. The trick here is that, and of course never do this, is that it doesn't matter how you write and how spacing works as long as it's parsable. So as long as the compiler can parse through what you're doing, it treats it as valid. Yeah. Oh, there was one quick thing I forgot to mention. So if we back up a few steps, because I have time, there was one of these tricks that you notice here. There's JavaScript and PHP. This trick doesn't work. Does anybody know why? First of all, did anybody see that first time around? Nobody called me on it. That's good. The reason this is because some languages, like JavaScript and PHP, treat all numbers as floating point numbers no matter what. And the floating point spec says that there is a -0 and a +0. Then therefore, the range of numbers is even on both sides. This trick doesn't actually work in those languages. So, quick digression there. So as we head to our last slide, so what did this do? So we said, basically says 11 as it approaches 1. This essentially prints 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Time for the next presentation. Thank you very much for listening.
Excellent. Thank you, Brian. Brian proving that there is absolutely no limit in talks you can create about the intricacies and nuances of JavaScript.
Yes, if I had to say this presentation as a moral, it's that even when you're writing test automation or tests, you can fall into these traps as well, so be very aware of them. So.
And I don't think we have any questions on the list, so if anybody has a question in the room, I guess my only question would be is why would anyone still use JavaScript?
It's getting better, so I hear.
Any questions? I think you've all stumped us.
Thank you very much for paying attention.
Thanks.
I appreciate it.